Every piece of food you eat has a hidden story. A story about how fresh it is, its quality, and most importantly, its safety. And most of that story, it's completely invisible to our eyes. But what if we could actually see it? Today, we're diving into a revolutionary technology that does exactly that.
So, just think about this question for a second. It sounds like something straight out of science fiction, doesn't it? The idea that a camera could glance at an apple and spot a bruise hidden deep under the skin, or scan a piece of chicken and know instantly if it's carrying microscopic contamination. Well, guess what? It's not science fiction anymore.
Here's the deal. The entire food industry faces this massive challenge of keeping food safe and high quality on a global scale. And so many of the biggest problems, we're talking bacterial spoilage, internal rot, contamination, are things we just flat out can't see.
For ages, we've relied on human inspectors, and they do an amazing job, no doubt. But the traditional method has some real limits. It's slow, it's a ton of work, and let's be honest, it's open to human error. Plus, a lot of the time, to see what's going on inside, you have to literally destroy the product by cutting it open. It's just not ideal for catching everything. So, to solve these invisible problems, we need a whole new way of seeing. We need something like a technological supervision, a way to see that goes way, way beyond what our own eyes are capable of. And that supervision has a name: hyperspectral imaging, or HSI. Now, here's a simple way to think about it. Your eyes see three main colors, right? Red, green, and blue. Well, an HSI camera sees hundreds of colors, including tons of light we can't see, like infrared. This lets it capture the unique chemical fingerprint of literally everything it looks at.
Okay, so how does this magic work? It's basically a three-step dance. First, you light up the food. Then, this special camera snaps a picture, but it's not a normal picture. It captures a massive data file called a hypercube, which holds that spectral fingerprint for every single pixel. And finally, some seriously powerful software crunches all that data and builds a complete chemical map of the food.
And once you have that chemical map, HSI basically becomes this incredibly powerful food detective. It's capable of spotting all sorts of things that were once completely hidden from view.
So let's start with those hidden defects. I'm talking about stuff like diseases, bruises, or decay that might not show any signs on the surface, but are already ruining the product from the inside out.
And this is where it gets really cool. Take a look. To you and me, that grapefruit on the left looks perfectly fine, right? But the HSI scan tells a totally different story. Those bright spots clearly show citrus canker disease. I mean, it's amazing. Systems using this technology can spot this on commercial sorting lines with over 95% accuracy. Okay, so spotting a bad spot on a grapefruit is one thing, but this ability to see the invisible leads us to something even more critical: food safety. Specifically, we're talking about detecting dangerous contaminants that can make people really sick.
And this number, wow, this is a total game changer. In poultry processing plants, studies show HSI systems can spot microscopic fecal contamination, yeah, not pleasant, but super important, with up to 98% accuracy. This is a huge leap for automating food safety and making it so much more reliable.
But this tech isn't just about playing defense and finding the bad stuff. It can also measure what makes food good. It can actually quantify things like taste and texture, all without ever having to touch the food itself. This slide just illustrates that perfectly. What you're looking at is a moisture map of beef generated by HSI as it dries out. Red means lots of moisture, blue means it's getting dry. It's wild. That same exact principle allows these systems to predict how tender a piece of beef will be with over 90% accuracy, or measure its fat content, giving a complete quality report on every single cut.
And it's not just beef, not by a long shot. The report card for this technology is pretty stellar across the board. Whether it's checking the tenderness of meat, the freshness of fish, or finding the perfectly ripe piece of fruit, HSI is proving to be fast, accurate, and totally non-destructive.
All right, so this all sounds absolutely incredible in a clean, controlled lab setting, right? But the real question is, how do you get this powerful tech out of the lab and onto the fast-moving factory floors that handle our food?
Well, this is how. This right here isn't some fantasy gadget locked away in a university. It's a real-world prototype. This HSI system is designed to work on an industrial poultry line, and it can inspect up to 180 birds a minute. That proves it can absolutely keep up with modern food production.
Now, of course, it's not all smooth sailing. Moving from a clean lab to a messy, fast-paced factory floor, that's a huge leap. there's still some major hurdles to overcome. We're talking about the high cost of the equipment, the insane amount of computing power you need to analyze data that fast, and just building systems that are tough enough to survive in an industrial environment.
But even with those challenges, the potential impact here is just undeniable. We are really looking at a future where our food is safer, higher quality, and produced with way less waste than ever before.
So why should you care about all this tech talk? What does it actually mean for your dinner plate? Well, it means safer food because contamination gets caught long before it ever has a chance to reach you. It means better quality, more consistency, getting that perfectly ripe avocado every single time. And it means a whole lot less food waste, which is better for the planet and for our wallets.
And hey, don't just take my word for it. The very researchers who are pioneering this work are incredibly optimistic. They believe we're on the cusp of a future where these real-time systems are just a standard part of how our food gets from the farm to our fork.
It really makes you wonder, doesn't it? If we can use light to uncover the hidden secrets of our food, what other invisible truths about our health, our environment, and our world are just waiting out there, waiting for the right kind of light to be revealed?